All right, hey there. I fell a couple days behind, so now we're going to try and move fast to catch up. So today is uh, day 22. Make this a little bigger. Good. Okay, so let's see, day 22. Sporifica virus. Diagnostics indicate that the local grid computing cluster has been contaminated with the sporifica virus. The grid computing cluster is a seemingly infinite two-dimensional grid computing node. Each node is either clean or infected to prevent overloading. Exactly one virus carrier moves through the network, infecting or cleaning nodes as it moves. Virus carrier is always located on a single node and keeps track of the direction it is facing. To avoid detection, the virus carrier works in bursts, and each burst it wakes up, doesn't work, goes back to sleep. The following steps are executed in order one time each burst. If the current node is infected, it turns right. Otherwise, it turns left. Turning is done in place. If the current node is clean, it becomes infected. Otherwise, it becomes clean. Virus carrier moves forward one node in the direction it's facing. Diagnostics have also provided a map of the node infection status. Clean nodes are shown as dot. Infected nodes are shown as pound. The map only shows the center of the grid. There are many more nodes beyond them, but none of them are currently infected. Virus carrier begins in the middle of the map facing up. So, for example, suppose you're given a map like this. Then the middle of the infinite grid looks like this. The virus carrier's position marked with virus carrier is on a clean node, so it turns left. Infects the node and moves left. It's on an infected node, so it turns right. Cleans the node and moves up. 4 times in a row, finds a clean, infects it, turns left, moves forward. See up, now on the same node as before, it sees an infection, it causes it to turn right, forward. After the above actions, a total of 7 bursts of activity had taken place. Of them, 5 bursts of activity caused infection. After a total of 70, the grid looks like this. By this time, 41 bursts of activity caused an infection. The most nodes have been clean. After a total of 10,000 bursts of activity, 58.7. After 10,000 bursts of activity, how many bursts cause a node to become infected? Do not count nodes that become infected. And let's look at our puzzle input, which is, okay. So because it's going to be infinite, we're probably going to need to store in a dictionary. So what we will do is, actually, let's just store a set of infected nodes. Okay, so what do I call this? Virus. Day 22 virus.py. Okay, and as always, we will let's just say from typing import a named tuple class xy, and this might be overkill again, but I always prefer named tuples to tuples, x int, y int. And what we want to do is we want to say, and let's call a grid here, and a grid is just going to be a set of xy. And I think set is something I can import from name tuple, so that should be fine. And let's just make sure that's the case. I know I ran into problems with something, but I think that was Q. Run day 22 virus.py, that works fine. Okay, good. And so what I want to do is first I want to def make grid, and let's say raw is a string, and that will return a grid. So, and I am going to do the following. Test input equals this thing. And so what do I want to do? I'm going to make x's go to the right and y's go up. So just a normal coordinate system. So what that means is that lines equals raw dot split on new lines. And let's just say num columns equals len of lines 0, and n row equals len of lines. Okay, and so, and what I want to do is I want to say a grid, which is a set of xy, is just an empty set. And now what I want to do is, so let's say left equals ncall divided by 2. I think that's right. And top equals nrow divided by 2. So for instance, if we have 3 columns, then the left is, actually it's minus this. 3 goes to the leftmost is -1. 4, we can't have 4 because it's center. 5 goes to -2. And similarly for the top. So, and so now all I need to do is just say for y, or let's just say for I in I row in enumerate lines, and for JC in enumerate row. So then X is left plus J, Y equals, and actually top is going to be this. So Y equals top minus I, and then grid, X, Y, X, Y, or no, grid dot add xy xy, and then return grid. Okay, and so we want to assert that make grid test input equals, and so what is this? This is going to have 1 1 and -1 0. 1 1 xy -1 0, and I think that invalid syntax because I need double equals local variable row reference before assignment because this is nrow assertion error. Okay, good. Make grid test input if C equals pound. So we don't want to add everything. We only want to add x equals -2, y equals 0, x equals 0, y equals 1. So we screwed that one up pretty good. X equals -2. So print nrow ncall, and 3 rows, 3 columns. So left equals -1. Let's say print ij. So that's 0, 2. So x equals -1 plus 2, and let's see, 0, 2, and 1, 0. So that's correct. So I must have messed up that math somehow. So if y is top minus I, so top should be print left top. Let's see if that's right. Left is that the problem? Yeah, that's the problem. So basically when I did minus, it rounded in the other direction because it was saying minus ncall instead of, so that's not what I wanted to do. So that was a stupid little mistake, but good to know. So now we have this carrier and class carrier. And what is the carrier going to have? A carrier is going to have a position which is going to be an xy and is going to equal, let's just say def init self pause xy equals xy 0 0, and direction, which is a string, which equals up. Okay, and self.pause equals pause, self.dir equals dir, and I'll call it direction because dir is actually means something in Python. Self.dir equals dir, and then we also want to do we want to count how many times it causes an infection. So self.infections equals 0. Okay, so that's fine. And now we also want it to be able to turn left and turn right. So turn right self if self.dir equals up, self.dir equals, so from up we want to go right, elif self.dir equals right, self.dir equals down, elif self.dir equals down, self.dir equals left, and then else, self.dir equals up, because those are the only choices. And then we're also going to have a turn left. And when we turn left, let me just copy this and just put in the opposite things. So from up, we go left. From right, we go up. From down, we go right. And from left, we go down. Okay. And finally, I think we also need to be move forward. Def move forward self. And let me just x equals and self.xy self. I'm going to regret making this immutable, so it's going to make my life difficult, but that's fine. Self.direction equals up. Self.pause equals xy. So for up, we want to go x, y plus 1. And let me just copy these. So for facing right, we want to go x plus 1, y. And if we're facing down, we want to go xy minus 1. And then otherwise, we want to go facing left, we want to go x minus 1y. So let's just make sure that this compiles, which I think it does. And so now we want to so now let us run. So given a grid and a, what is this called? A carrier and num steps, which is an int. And we are going to do the following. For blank, for I in range num steps. Okay, so what do we want to do? Pause equals carrier.pause. If pause in grid, so that means that we're infected. Turn right. Carrier.turn right. And then grid dot, how do I remove from a set? X equals 1, 2, 3. Remove 1. Okay, so grid dot remove pause. Otherwise, I want to carrier dot turn left and grid dot add pause. Okay, and then the virus carrier moves forward, and then carrier dot move forward. And so already infected, disinfect. Say not infected, so infect. And then we also want to say carrier dot, and what did I call that? Infections plus equals 1. So that should be good. And so let's just say test grid equals make grid test input assert test grid equals that. And now what we want to do is we want to run test grid an empty carrier and 70 steps. Assert that let me do this. Test carrier equals carrier. Test carrier. I'm going to assert that test carrier dot num what did I call it? Dot infections equals 41. So let's run that and see if it works. Okay, let's look at test carrier. That's not what I wanted to do. I wanted to do this. And then let's look at test grid, which and let me just make a new grid each time. That will be better hygiene, I think, because it gets destroyed. And let's just try 10,000 steps and 5587. So if that's right, that's probably a good sign. Okay, good. So that's a good sign. So if name equals main, and we have this grid here. So let's save as day 22 input.text with open day 22 input.text as f raw equals f dot read dot strip new line grid equals make grid from raw. And let's just print the grid and just see what it does. So let's say len of raw dot split n, so that's 25, and this will probably also be 25. Good. So if it's 25, that means the top y is 12. So let's just say pause for pause in grid if pause dot y equals 12. So we get, x is -1, -2, not -3, not -4, not -5, but yes, -6, -7, not -8, -9, plus -10. So that looks pretty good too. And then let's look at the bottom row. If y is -12, and let me sorted. Okay. So I get -11, not -10, -9, -8, -7, not -6 or -5, yes -4, yes -3, not 2, 1, yes 0, not 1, 2, 3, 4, yes 5. Okay, so those look right. And so now what is the question asking? The question is asking, after 10,000 bursts of activity, how many bursts? Again, let's make a carrier equals carrier run grid carrier 10,000 and then print carrier dot infections. Okay, so let's run that. 5433. Okay, so that seems reasonable, and that's the right answer. Good. So, part 2. As you go to remove the virus, it evolves. Now before it infects a clean node, it will weaken it to disable your defenses. When here's affected node, it will instead flag the node to be clean in the future. So clean nodes become weakened nodes become infected nodes become flagged nodes become clean. Every node is always in exactly one of the above states. The virus carrier still functions in a similar way, but now uses the following logic. Start with the same map, start with the same virus carrier, drawing weakened as W and flagged as F. Okay, so I think what we're actually going to do is we're going to make a copy of this because we need to just basically modify it in place. So let's copy this, add a new file, day 22 virus part2.py, and just start over again. So now before it infects a clean node, it will weaken it to disable your defenses. If it encounters an infected node, it will instead flag the node to be clean in the future. Now we're going to say that instead of a grid being a set, it's going to be a dictionary from XY to strings. We should really do an enum, but I can't remember how enums work. Let me look that up real fast because I think that's probably better. Enum, Python. Oh, that's pretty easy. From enum import enum. And then what did I say about this? I said every node is always in the following one states. So let's say class state, which is enum, and I just do clean weakened infected flag. So clean equals 0, weakened equals 1, infected equals 2, flagged equals 3. And so I'm going to say my grid is actually a dictionary from XY to state, but I'm actually not going to store clean as the state. I'm just going to leave it empty. So now what I'm going to do is I'm going to say if it's infected, grid this equals state dot infected. And I think that's right. Start with the same map, still using that for cleaning, that for infected. Start with the virus carrier, still starting in the middle and up. Then I'm worried about speed here too, but we'll deal with that when we deal with that. Okay. So we'll instead weaken it. We'll instead the flag the node to be cleaned. So now use the following logic. Reverse direction. Okay, so now what we need to do is, well, this is actually, let's cheat a little bit. Def reverse self, self dot turn left, self dot turn left. Okay, so that's one way to reverse. It's just to turn left twice, and that's what I will do because that's quickest. Modify the state and then moves forwards. Okay, so That's fine. And now what I want to do is, instead of doing this if pos in grid, we're going to say state equals grid dot get, and actually it's, so there should be state dot infected, and this should also be state dot infected. Okay, good. So state equals grid get pos, and then the default will be state dot clean, because if it's not there, we're just going to say it's clean, which is fine. And so now if state equals state dot clean, so what happens if the state is clean? We want to turn left, carrier dot turn left, and then we want to modify the state of the current node as described above and becomes weakened. So that means that grid pos equals state dot weakened, which is fine. So elif state equals state dot weakened. Spelled that way. So if it's weakened, it does not turn, and it will become infected. So grid pos equals state dot infected, and then otherwise, if state is state dot infected, it turns right. So carrier dot turn right, and then an infected node becomes flagged. So grid pos equals state dot flagged, and otherwise it's flagged. And if it's flagged, it reverses direction. So carrier dot reverse, and it becomes clean. So we will just remove that from the dictionary. And also we need to weaken becomes infected and add to the infections, and then finally we move forward. So of the first 100 bursts, 26 will result in infection. So let's just change that test. 126. So set object does not support item assignment. So let's think about that. Let's look at make grid. So where are we getting a sets? 34. Oh, because grid is going to be dixt xy state equals empty. So now let's try this again. And that worked. And what is this, 10 million? Let's that is a lot. The question is, how long will that take to run? Probably a lot. So let's see. And let's just print, if I mod 100,000 equals 0, print I, and that will just give us a sense of how long it will take to get to 10 million. Okay, so not too long. I mean, it'll take a little bit of time, but we're up to 1 million right now, so that's totally reasonable. And let's hope it gives us the right answer, and then we'll run it again for our actual input. And then I guess I'll comment out that test because I don't want to waste the time for it again. Wow, this thing runs through battery when I'm recording. I'm not plugged in right now, so I didn't think it would be a big deal, but it's looking like it's using a lot of battery. So hopefully this gives me the right answer. And I did not, oh, I passed my assert. Okay, so that's good. Test carrier. Yeah, so that's great. So let me comment this out, uncomment this, and run it 10 million times, and let's just do that again. And again, it's going to take a while, but I feel good because I used enums, and they were probably the appropriate thing to use here, and I haven't really used them much, and so you can tell because I had to look up how to use them. But in a problem like this, they seemed like a smart way to model things. And I mean, if I got the right answer on 10 million iterations of the test grid, I'm probably going to get the right answer on 10 million iterations of the actual grid as well. But you never know. So it's getting there. It's getting there. It's getting there. It's getting there. I have a weird feeling they wanted to give you like a gotcha where you were, trying to store things in an actual grid instead of a dictionary. But since you don't know how that grid is going to be, 251, 2599. So let's plug that in, and that is the right answer. 1 gold star closer. So that completes problem 22, and I could do problem 23 because it's available, but I would like to take a break, I think. So I'm not going to do that right now. But as always, you can find me on Twitter at Grus. That's me. And thanks for watching.